Hello my dear students, welcome to NAK Academy. In this video I'm going to discuss simultaneous equations with fractional coefficients. As you remember that we have discussed with this chapter starting with solving simultaneous equations, which included positive and negative integers. So this is the next section of the chapter, equation. So let's look at a couple of questions under your exercise, and let's try to solve these simultaneous equations which include fractional coefficients. So I'll take the very first question, that is 3 over 5a plus 1 over 3b equals to 3. So that is my first equation. And my second equation is 1 over 2a minus 1 over 3b equals to 8. So that is my second equation. So now since this is the very first question, so I took the very easy question for you to solve, so you can understand well how to simplify these simultaneous equations, which includes fractional coefficients. So as you can observe here, the coefficient value of b is 1 over 3, that is a plus value, and the second equation, the coefficient of b is minus 1 over 3. So both the instances values are equal, so therefore I don't need to do any changes. Simply I can add equation 1 and equation 2 since the operators are different, so that I rewrite as 3 over 5a plus 1 over 3b plus 1 over 2a minus 1 over 3b equals to 3 plus 8. So 1 over 3b I can simply eliminate, I can cancel. So the remaining terms are 3 over 5a plus 1 over 2a equals to 11. So now this is simplifying a simple equation. Now no more it is not a simultaneous equation. The simultaneous equation we have simplified into a simple equation. So here you can see that denominators are different, 5 and 2. So you will basically find the LCM. LCM is 10. So then you simplify the numerator. So I am not going in detail on how you simplify these fractions which includes different denominators, because we have already discussed this in our previous video sessions, which is algebraic fractions, and even in the simultaneous equation, my very first videos. So you can go through those videos and you can get the idea of it. So now the numerator comes as 11a over 10 equals 11. Now I need to subject a, so that means 10 is a divisible value, division. So when I shift it to the other side of the equation, that changes to multiplication. So 11a equals 11 multiplied by 10. So no need to hurry on multiplying these values, because as you can see, we can further simplify these numbers. So therefore when you are doing simultaneous equation questions, check whether any numbers can be simplified, or in other words we can divide. If so, you can divide and continue finding the answer rather than multiplying the numbers. So now you can see 11 and 11 can be cancelled here. So the value of a is equals to 10. So now I found the value of a. Now we need to find the value of b. So simply you can substitute the value of a either to equation 1 or equation 2, as we did in the previous exercises. Okay, I think I found only the value of a. that would be fine. So simply you can do this workout and just try to find the value of b in this question. So let's go to the next question. So that is 3 over 5x minus 1 over 2y equals to 9. That is my first equation, and the second equation is 1 over 4x minus 1 over 2y equals to 2. So this is also, you can find the coefficient of y values are same. Fraction is minus 1 over 2. So both the instances it is minus 1 over 2. Since the operators are same, as I mentioned earlier, you can subtract. So I'm going to subtract equation 1 from equation 1 to equation 2. So I write 3 over 5x minus 1 over 2y. Since I subtract, I said earlier also I said, so I'm repeating again, second set of terms always you write within brackets. So minus, we write 1 over 4x minus 1 over 2y equals to 9 minus 2. So here you can see I can cancel this 1 over 2y and plus 1 over 2y with minus 1 over 2y. So the remaining terms are 3 over 5x minus 1 over 4x equals to 7. Again the denominators are different, so we find the LCM. So LCM is 20. Then you simplify the numerator. 20, how many 5s are there? 4. So 4 multiplied by 3 is 12. 12x is mentioned here. 20, how many 4s are there? 5. 5 multiplied by 1 is 5x. So now you can observe some pattern, like each and every question we are doing the same set of work again and again repeatedly. We remove one term by adding or subtracting the equation. We check the coefficient first, then we remove one term, then we check with the remaining terms. That comes like a simple equation. Then we solve whether the denominators are different. We find the LCM and we simplify the value. So it is very simple. So here you get 12x minus 5x equals to 7 multiplied by 20, because this is division, divided by 20 no. So when you shift it to the other side of the equation, it's multiplied by 20. So you get 7x, because 12x minus 5x is 7x equals to 140, or otherwise you can just write as I said before and you can cancel 7. So you get the value of x equals to 20. So now you can substitute x equal 20 either to equation 1 or equation 2. So I'm taking the first equation, then you substitute as shown here. So you replace x value with the whatever the value you found. So in this question it is 20. So now you can see 5 and 20 can be divided. 5 divided by 5 is 1, 20 divided by 5 is 4. So you get 12. 12 minus 1 over 2y equals to 9. So I subject y here, so I shift this 1 minus 1 over 2y to the other side of the equation, and I shift 9 because it's a number. There is a number here also, I need to solve the number. So I shift plus 9 to the other side, so that changes to minus 9. So 12 minus 9 equals to 3 and 1 over 2y. So 1 over 2y equals 3, therefore y equals 2 multiplied by 3, which is 6. So this is also very simple way that you can find the values of x and y. Both the examples what we did right now is the coefficients are same for both the terms in the equations. When coefficients are different only, we have little more work to do, as we did in the previous lessons or previous videos. First we have to equate the coefficient value. So let's look at another question. 1 over 3x plus 1 over 2y equals to 4. 1 over 2x minus y equals to 1. So that is my second equation. So now in this question you can see that coefficients are different. There is no equal coefficient where we can directly add or subtract the equations and eliminate one term. We can't do that here. So I take the second equation and I simply multiply by 1 over 2 so that I can make this y as 1 over 2, the coefficient as 1 over 2. So what happens is, each and every term I need to multiply by 1 over 2. So 1 over 2 multiplied by 1 over 2 here, 1 over 4x minus 1 over 2y equals 1 multiplied by 1 over 2 is 1 over 2. So I'll label that as my third equation. So now I can take the first equation and third equation and I can solve this to find the value of x. So when I add the first equation and the third equation, simply you can see that plus 1 over 2y get cancelled with minus 1 over 2y. So my remaining terms are 1 over 3x plus 1 over 4x equals to 9 over 2. Now here we can find the LCM. Again the same thing we are doing. So LCM is 12. So here when you simplify you get 7x. 7x over 12 equal 9 over 2. So as you can see, 12, it is division. It's a division. So when you shift to the other side of the equation, it changes to multiplication. So 9 multiplied by 12 over 2. Why I didn't multiply? Because I can cut this number, so I can simply divide. So I get 7x. So 7 also you can again shift because 7 multiplied by x. So when you shift here, it changes to division. So you get 2 and 12 I can divide. So I get here 6. So my answer would be 9 multiplied by 6 is 54 over 7. Now I can substitute 54 over 7 to the second equation. So I take the second equation, so it's easy to simplify. So just replace the value. X is 54 over 7. Now you can see 2 and 50 can be simplified. So that is 27 over 7. So what is y is, you can just subject y. So you get y equals, because you can shift minus y to the other side, it changes to plus y. So 27 over 7 plus 1 you can shift to the opposite side. So that changes to minus 1. So here this is just a simple fraction you need to solve. So you get 27 over 7 minus 1 is when you find LCM here 1 over 1. So actually you don't need to find LCM at all. You can simply take 7 multiplied by 1 is 7. 27 minus 7 is 20. 20 over 7. So this is how you find when the coefficients are different for given simultaneous equation. So you make sure first check the fractional coefficient and make equal the coefficients in order to eliminate one term. So with my next video I'm going to discuss a couple of examples related to this fractional coefficients. So like this video and share this video with your friends, and subscribe our channel NAK Academy. So thank you.